Thank you, sir, for accepting our invitation. I now invite our Honorable Guest of Honor, Professor Ganta Chakrapani Garu, Director, Academic. Please come on to the dais, sir. And I warmly invite our beloved Dean, Faculty of Science, Professor G. Pushpa Chakrapani Madam, to join on the dais. Now, I call upon Dr. Vijay Ushasri to present a bouquet to our Vice Chancellor, Professor K. Sitaram Rao Garu. Thank you, Dr. Usha. I invite Mr. Koteshwar Rao to present a bouquet to our chief guest, Professor Peter Tilvi Garu. Thank you, Koteshwar Rao. I invite Dr. Vijay Kumar to present a bouquet to our academic director, Professor Ganta Chakrapani Garu. Thank you, Dr. Vijay. And I invite Mr. Kumar to present a bouquet to our Dean Madam. Thank you, Kumar. I thank each and everyone for attending this program. I will now hand over this session to the President of this event to conduct the proceedings. Thank you, sir, and thank you all.
Namaskar. Good morning, everybody. Now, I invite Dr. Rajita Madhavi for prayer song. Then lighting up the lamps today.
नील सिंधु जल धौत चरण तल अनिल विकंपित श्यामल चल अंबर चुंबित भाल हिमाचल शुभ्र तुषार किरीटिनी देवी भुवन मन मोहिनी निर्मल सूर्य करोज्वल धरणी जनक जननी जननी प्रथम प्रभात उदय तव गगने प्रथम सामर तव तपोवने प्रथम प्रचारित तव वन भवने ज्ञान धर्म कथ काव्य काहिनी देवी भुवन मन मोहिनी निर्मल सूर्य करोज्वल धरणी जनक जननी जननी चिर कल्याणमयी तुमी धन्ये देश विदेशे वितरिचन्ते जाह्नवी जमुना विगलित करुणा पुण्य पीयूष स्तन्य वाहिनी देवी भुवन मन मोहिनी निर्मल सूर्य करोज्वल धरणी जनक जननी जननी चिर कल्याणमयी तुमी धन्ये देश विदेशे वितरिचन्ने जाह्नवी जमुना विगलित करुणा पुण्य पीयूष स्तन्य वाहिनी देवी भुवन मन मोहिनी निर्मल सूर्य करोज्ज्वल धरणि जनक जननी जननी जनक जननी जननी जनक जननी जननी.
Now I request all our guests on the dais. Now I request our Dean Faculty to make a brief introduction about the National Science Day program.
Very good morning to you all. Respected Honorable Vice Chancellor, Professor K. Sitaram Rao Garu, President of today's National Science Day program, a very distinguished scientist and Indian American astronomer, Dr. Vithal Tilvi Garu, Chief Guest for the program, respected Director Academic, Professor Kanta Chakrapani, Guest of Honor for today's program, and our Registrar, Dr. A.V. Reddy Garu, our former professors, Professor Venkatai Garu, Professor Rajshekar Reddy Garu, other directors, deans, heads of the branches, teaching and non-teaching fraternity, and my dear students. Once again, a very warm welcome to you all to this National Science Day celebrations organized by Faculty of Science, Dr. B.R. Ambedkar, Open University. You all know National Science Day is an annual celebration observed in India on 28 February to commemorate the discovery of the Raman effect by Indian physicist Sir C.V. Raman. This discovery, which earned Raman the Nobel Prize in Physics in 1930, it is marked a significant milestone in the field of science and put India on the world map of scientific research. We, particularly the scientific community and people of science in India, celebrate this National Science Day as one of the festivals every year. So celebrating National Science Day is a great occasion to recognize the contributions of our scientists and their role in shaping the world what we live today. It is also an occasion to highlight the importance of science in the world and to raise awareness of the values of scientific theories and applications in our daily life. It is also an opportunity to display all the activities, efforts, and achievements in the field of science for the welfare of human being. And it is also an occasion to encourage your young minds to take up science subject and to popularize the science and technology. And we know every year the National Science Day is celebrated with special theme. And this year, the theme for National Science Day 2023 is Global Science for Global Well-Being. So it is in our university every year we invite a distinguished scientist from different fields, and now we have with us Dr. Vithal Tilvi, Professor, Research and Development Innovation, State Higher Education Council, Directorate of Higher Education, Goa, to share his knowledge and great experiences to all of us by his talk on exploration from deep ocean to deep space. I'm also feel proud to inform you that he is the founder of the farthest group of galaxies. Sir, really we're honored today by your presence here as the chief guest for this National Science Day. And thank you very much for accepting our invitation, though you are busy attending government programs at Goa. Sir, you know, Dr. B.R. Ambedkar Open University is the first open university in India, established 1982 by the Act of State Legislature. And since inception of this university, the science programs have been offered at an undergraduate level, and later on we have shifted to, we have started postgraduate programs also in 2008. By the demand from the society and well as the stakeholders, we have introduced our research programs also in 2018, sir. And this is, as I have discussed in the morning, this is a very brief introduction of our university. And I once again thank each and every one for attending this National Science Day celebrations. And my dear students and faculty members, as Dr. APJ Abdul Kalam says, imagination leads to creativity. Creativity blossoms thinking. Thinking provides knowledge. Knowledge makes you great. So by taking his words as inspiration, we, the Faculty of Science and our students, have tried our level best to showcase our imagination into creativity that provides knowledge of science in the form of science exhibition, which is organized very opposite to this hall. Sir, this is a very little effort of our students. So after chief guest speech, I invite all of you, please visit the exhibition and encourage our students to do better in future. Sir, as we discussed in the morning regarding the accessibility and opportunities, here is an example of Dr. B.R. Ambedkar Open University. So Dr. B.R. Ambedkar Open University is trying to reach the unreached people in the state and in the country. And here is an example. I feel proud to share with you all that one of our university students who has doing now her MSc Physics in the first year, she has developed a model along with his students for NASA. And we are going to see it in our exhibition today. And she also received the Inspire Award in district level Science Expo. This is an opportunity, this is the accessibility given by the Dr. B.R. Ambedkar Open University, such kind of students. So, also there are some more items from different departments. Please visit along with us and share the joy with us. So thank you very much once again for attending this program. I thank our Vice Chancellor, Registrar, Direct Academic, and all our colleagues joining with us for this celebration of National Science Day. Thank you one and all.
Morning, everybody. Once again, I extend warm welcome to you all, and especially to our chief guest of the day, who is the main speaker of this program, National Science Day. Professor Ganda Chakramani, Director Academic, Professor Pushpa Chakramani, Dean Faculty of Science, who is the main organizer of this program, and Honorable and respected Professor Vittal Dilvi, very popular scientist, astronomer. I don't know whether I should call it an astrographer. And he tried to map the galaxies, stars, in the deep space. And he's doing a great job of chairman of Research and Development Innovation Office of Goa government. Recently, I went to Goa as a NAC peer team visit chairman to assess a government degree college, where I could meet him I was really fortunate enough to meet him there. And within no time, he became a good friend of mine. To be frank enough, I fell in love with him for his study, research, and his attitude towards science, and his attitude towards popularizing the science among the public. So that is the reason I decided to invite him to this National Science Day program. So thank you very much, sir, for accepting our invitation within a short time. And also you have made possible to come over here all the way and to speak a few words, to encourage us, to inspire us about the science and scientific temper and science awareness. So thank you once again, sir. So I am not a scientist, to be frank enough. But as a general reader, I have some sort of curiosity to know about the Khagola Shastra. That is space, science of space. So when I was telling him, I happened to read in my undergraduate days the popular science books written by Nandur Raman Rao. Chakrapani also knows Vishwarupam, Naravataram, Vishwadarshanam, 2 parts, Western philosophy and Eastern Indian philosophy. These are the books really inspired me very much to know about the science. After reading this Vishwarupam in Telugu of Nandur Raman Rao, really I wondered, what is our place in the entire universe? There is a saying in Sanskrit, Brahmandam nundi Pipilikam daka. Pipilikam ante chaala chinnadi kada cheema. Brahmandam ante mottham Vishwam. Manam cheema kante kuda china. Manam cheppali. So that is the thing. It will amaze us to know our place in the universe. But I also told him one more thing when we were discussing. I spent quite a good time with him. And I told him that recently in 2018, during the October 1st week, AIU published, I told this last time also. There was one interesting article written by A.V. Mohari. He's a physicist basically, worked in agriculture, Indian Council of Agriculture Research in New Delhi. And he wrote a wonderful article titled Science, God, Spirituality. Science, Spirituality, and God, an attempted synthesis. Really, I was very much inspired by this article. And I requested one friend of mine, Telugu journalist, Mr. Jorbara Balashekar Sharma. He translated those articles into 9 articles published in Namaste Telangana, the science page also. So this is my general interest about to know about the science and scientific happenings around us. So, according to me, as I learned from the different sources of science reading or popular science articles published in various journals and news magazines and all that, we know very little about the universe. Scientists say that the happenings in micro world, happenings that are taking place in the macro world are being governed by certain basic scientific laws. That is atom. అణువు కావచ్చు, పరమాణువు కావచ్చు, మొత్తం విశ్వంలో ఉన్న పెద్ద పెద్ద గెలాక్సీల కూడా కావచ్చు. బేసిక్ గవర్నింగ్ ప్రిన్సిపల్ మాత్రం దానికి కొంత సిమిలారిటీ ఉంది, సేమ్ అనేది నాకు ఇప్పటికీ కూడా ఈవెన్ నౌ so many things are beyond our knowledge, beyond our exploration, beyond our imagination also. This topic is also very interesting here. Exploration from deep sea to deep space. Very interesting. And the lecture is, there is a window. We are trying to see through a window. That is the window available to us, through which we are trying to see or observe or know things what is going on. So at the same time, A.D. Maharaj says same thing. It is a continuous interplay between matter and energy in the universe is the key important aspect. It's an interplay. అంటే అంతఃక్రీడ. This interplay sometimes visible, sometimes invisible. And there is also one important saying that the entire universe is like a money harp connected by invisible thread. So making that invisible thread is visible is the science, knowledge. So that is the point we have to understand. So I don't want to speak many things before a great scientist, so many things than us, out of only our curiosity, general interest. So scientists say that even now in the universe, we are able to see only 4% of the matter. Remaining 96% of the universe is filled with the dark matter and dark energy. We don't know what is there in it. Still, it is explorable and known. And at the same time, what are the they identified seven basic elements in the universe. One is matter, energy, light, sound, space, time, and also seventh item. This is apart from the seventh item is bioconsciousness. Biological consciousness is also part of the seven basic elements of the universe. Apart from this, they have also, scientists identified 5 primary forces also, which are operating between interplaying between the matter and energy. That is magnetic field, electric, electromagnetic field, Vidyutayaskanta kshetram. Then gravitational, Gurutvakarshana. And fifth one is destructive super gravitational force. That is part of the galaxies, and that is there. Vidhvansaka Vishwagurutvakarshana. We think that whether it is space is expanding or contracting, this is the basic question. Scientists are mind-boggling question they are facing. Then, if it is contracting, it will become zero, dark matter, black holes, don't know, all these things. Then, the sixth item, as I have said, the biological consciousness. These are the major primary forces which are part of the universe and nature. So these are the things we have to encourage: scientific temperament and scientific awareness. We have to popularize this science among the students from the undergraduation level itself. We have physics, chemistry, botany, zoology, geology. Why we should not have astronomy also? I suggest our science teachers to think and evolve a program to introduce astronomy as one of the optional, like we have to do statistics. Why we should not think of introducing astronomy? It doesn't need much laboratory facilities, as Sir was telling. In this regard, our chief guest, honorable chief guest, will definitely help us in evolving some astronomy course at the undergraduate level, so that let us create some astronomy. Earlier, Usmania University was famous for astronomy research. You know, these Nizami observatories were there in present CES building. Now, no astronomy, no interest, no one is taking care. So, we should also create interest for the younger generation in the field of astronomy. Thank you very much for giving me this opportunity. I thank once again our chief guest for accepting our invitation and coming over here. Thank you once again. Now I request our Honorable Director, Professor Chakrapani, to do his brief message.
Thank you, sir. Good morning, all the dignitaries on the dais, and also students, teachers, non-teaching staff attending this very warm morning session of National Science Day, celebrated by Faculty of Science and KPR and the University. I don't want to take much time because our Honorable Vice Chancellor, who is keen in philosophical aspects of the universe, very, in detail, he explained the origin of the universe and, its parts and components. And the next speaker is a very celebrated, scientist, astronomer, NASA scientist, who himself led a team to invent a beautiful galaxy which is 13 billions away. Am I right, sir?
Light years.
13 billion light years away to the Earth. And he invented that with a small Hubble, telescope. And that record is on his name in NASA. And he is visiting professor of, many universities in America and, India. I was just, having a small discussion with him, before we come over here. And he's very humble and, is very patriotic in a way. He's serving his state, as a professor of science and technology in Goa. Many people in India, including C.V. Raman, on whose name we are celebrating this day, on his invention of, Raman effect. I mean, the reflections of lights on water and, sky and whatever. I'm not a science student. He is also like our Vital Dilvi. He is also from very humble background. He's not a school teacher. And of course, he's a Telugu born and a Telugu grown-up person, C.V. Raman. In Vizag, his early childhood and his education, initial education he has completed. From very humble background to, till today, not only till today, as long as science lives in this world, his name will be there. That's right. And, another proud, very kind of thing regarding C.V. Raman is the first academician to receive Bharat Ratna. And actually, his for the benefit of our students, is a ICS officer, civil services officer. But he also, like you, after serving, after doing some job, he took distance education in a way. He just attended the meetings of Science Enthusiasts Association or something in Kolkata, and he started doing his research independently. And then he turned and he went to laboratories in America and India, and he took up that research independently. It is his inner inquisitive, his inner thirst towards research that made him to a great man and a celebrity and a kind of a pathfinder to Indian science and technology research. Believe me, we may have complaints on several issues in regard to economic front and development front, or political uncertainties on Indian system. But we must feel proud for the achievement of Indian science and technology. In that field, in fact, we are really number one in several sectors, several areas, particularly space research, and particularly ocean research, and particularly science and technology innovations and advancements. Galaxy, India is headquarters for that kind of research, and NASA is doing wonderful experiments in science and technology. Today, it's a great day in our history of your science department, madam. You are really organizing a very, very interesting program today, because we have very legendary scientists among us, and he is going to discuss maybe his innovation as well as the future of science and technology. And this is going to help our students, not only our students, and this is going to kind of another feather in our university's hat. Definitely, this celebration may motivate our students. Already, sir, though we are a distance education institution, and our students come to our campus very frequently for practicals and classes, and they themselves, they have started small experiments and small exhibitions. Today they are displaying here. Your presence over here, it is going to definitely motivate them. Thank you for coming over to Hyderabad. As you know, sir, Hyderabad is, I say it's the capital of science and bioscience, biotechnology, as well as pharmaceuticals, and now in different other sciences. I mean, IT and other sectors. We are in Hyderabad is emerging like as a hub of scientific temperament and scientific knowledge. Thank you, sir. Thank you on behalf of teachers of faculty. I welcome you, and I wish the program a grand success. Thank you, ma'am.
So thank you very much, Professor Chakrabarty. Now I request Pushpa Chakrabarty to introduce two guests from the audience.
Thank you, sir. It's really a great honor for me to introduce our chief guest today. I don't think I am suitable to introduce him, but I try to put it whatever I know from the script you have given, sir. And I just compel and I'll read out that one. Dr. Vittal Pilvi, Indian-American astronomer, along with his team of NASA astronomers, made a breakthrough discovery by finding the farthest group of galaxies to have ever been sighted, named EGS 77. It is a ratio of galaxies which is 13 billion years away from the Earth. The discovery of EGS 77 is significant as it assisted the researcher to study the birth of the universe by identifying the chemicals present in the newly found group of galaxies. A big applause to Dr. Vittal Pilvi. In 2013, Dr. Pilvi discovered the farthest single galaxy ever sighted by astronomers. Now, after 4 years of research, he found that there is an entire group of galaxies, which is a significant discovery of EGS 77. It is the first galaxy group caught in the act of cleaning out the cosmic fog. Dr. Vittal Pilvi did his PhD in astronomy and astrophysics School of Earth and Space Exploration, Arizona State University, Arizona, USA in 2011. And he did his MS in Physics, Michigan Technological University, Michigan, USA in 2006. And he completed his MSc Electronics Science from Goa University in 1997. His association with this is, he is the research associate at Texas A&M University and Arizona State University, USA during 2011 to 2017. And he worked at NIO Goa, National Center for Antarctic Ocean Research, Government College, Government Polytechnics, PES Higher Secondary during 1997 to 2003. So his research interests are his studying universe during its birth using cosmological simulations and observations. And he is the author of more than 40 research publications in international journals. And he is a reviewer for 3 international astronomy journals. And he is the principal investigator for 3 NASA-funded projects using the Hubble Space Telescope and Rodger Doxey Prize for top 10% PhD thesis by American Astronomical Society in 2011. And he is currently the project leader for a NASA-funded project to study a black hole that he discovered back in 2017 using observations taken by the Hubble Space Telescope. He's also part of NASA's Wide Field Infrared Survey Telescope team, which is going to be launched in 2025. Besides, he is a visiting researcher at the School of Earth and Space Exploration at Arizona State University and contributes to the State Higher Council of Government of Goa as a professor of research, development, and innovation. And his notable research contributions are discovery of the farthest group of galaxies in the universe in 2020, listed among the top 10 discoveries of 2020 by Astronomy magazine, a discoverer of the earliest black hole candidate in the universe 2017, and he is the team member discovery of the most distant galaxy in the universe in 2013, and he is the lead author for discovery of 3 new galaxies. This is a very, very brief introduction about Dr. Vittal Hilvi Garu. Really, you youngsters and young students are really fortunate enough to listen to his great lecture. So thank you very much, sir, once again for accepting the invitation and come to our university. Thank you.
So thank you very much for that point. We are waiting since long time to hear Dr. Vijay. Now I request our chief guest to give his address. Thank you.
Thank you and very good morning. Respected VC sir, he's a writer, communicator, and above all, he's a risk taker. I will tell you in a minute why. Respected madam and respected sir, I'm really fortunate to address especially the talent we have in India. And we were just discussing in the morning. So I spent some time in US, about 15 years in US. I'm the same person in India. Nothing changes when you fly from India to US. However, the environment, the academic environment and the environment we have in the educational institution can really make a big difference. So I'm the same person with same intellect, nothing changes, right? When you fly from over the Pacific Ocean. And so what really matters is the environment we give to the students. And that is what I see. I've gone through the profile of Ambedkar Open University, and we have that kind of environment. And if we are able to make use of the facilities that we have to maximum efficiency, there is no reason why we cannot have that kind of people reaching to the level what we are supposed to reach. And so thank you for the invitation. I'm really honored to be here, to be part of celebrating as National Science Day. So let me switch over to the presentation. And I think this is the first time somebody has you can share the presentation. Yeah. First slide of first slide. First slide of So I think this is the first time somebody has recognized what it really means to have this slide. Professor Rao rightly saw, this is really the window to the universe. And when we go to any institution just serves as a window to knowledge. And that was the intent. So this is really a window where we get the knowledge. And of course, I have experience working in oceanography and more recently in astronomy. So it cannot get better than this. So why I said Vice Chancellor is a risk taker, you are expecting somebody like this, right? Turned out to be somebody like this. And so what it really takes to discover something, to invent something, right? Of course, some of you might have already guessed. So this is the original picture. So, and I grew up in a small village. I still live in a village. You might not know that Goa also have villages. Of course, they are not anymore like it used to be, but Goa also have villages. And I grew up, I still stay there. The advantage staying in a village, staying in a rural place is, of course, you can see stars, which you cannot from light polluted cities, especially now. A lot of light pollution, a lot of pollution in general. And so I had that advantage. I looked at the sky for, every night, essentially every night. And so that gave me an advantage to see what you cannot really see from the cities. You can see stars that you cannot recognize from the cities. And so I think that is where I started loving astronomy unknowingly, but that is where it all started. So I worked in an institute called National Institute of Oceanography. And briefly, I will tell you what was my experience there. I don't know how many of you have been on ship, not trawlers, but real big ships. So this is one of the research vessels. They are also called vessels. This is quite big, about close to 100 meters long. You can, in fact, cricket on the same ship named Sagar Kanya. And so when I was working in this oceanography institute, we used to really go deep in the sea. That means close to equator. We will go there, stay there for about a month. And I don't know how you feel staying in ocean for about 45 days, where you can see only water. You can see only three things when you go that deep in ocean. You can see sunrise, sunset, and water. Only three things you see. And you can imagine, you get fed up of seeing the same people on the ship for 45 days, for a month. You really, and you cannot get down, right? It's deep in the sea. Even if you want to come back, it will take another 3 or 4 days to come back on the land. And so in 1998, and the project was to study how cyclones form in the Bay of Bengal. It affects, in fact, Andhra Pradesh, Telangana, Orissa during the monsoon season. And the experiment itself was to study how cyclones form during the monsoon. And so we had to go during the monsoon when it rains. And when we were about to come back on the land, just 3 days prior to that, this was in 1998, 3 days prior to that, that cyclone started forming in the ocean. And you might have heard there is a calm before the storm. It's really true. That is really true. That means now we had an idea. So what happens in the ocean is that there is something called low depression. You might have heard of low depression. That means low pressure area will form, and now a lot of things will come together. It will start circling, and that is how the cyclones form. So before that, everything becomes sort of very calm. That means you can see few kilometers. Otherwise, you cannot see that long in the ocean because there are a lot of waves and the sea is very disturbed. But before the cyclone forms, everything is very, very smooth. And the experiments that we were doing is we will put some instrument. It will go about 1 kilometer below the sea surface, and then we collect all the samples. That means we have to put some instrument using cranes, and then we will take the instrument out after some time. So it takes some time. So we realized that now there is a low depression area, that means low pressure that is forming. And we were trying to bring that instrument up, which is collecting the sample. It took about 1 hour. Within that 1 hour, things change so badly. That means there is a sea level and the ship, that is the deck, is about 6-7 meters above the sea level, right? Above the sea surface. Within 1 hour, the waves were so rough that the water came onto the deck, just within 1 hour. And things got so bad that some of the things that were on the platform, on the deck, so this side water came and then it went on the other side. And a lot of things from the deck went into the sea. We quickly packed everything. We were just fortunate to bring that instrument from the sea onto the deck. We kept it outside on the deck. We went inside. Inside, my research supervisor was holding another instrument because ship will pitch and roll. It was so rough, and that on the ship, what is done is all the instruments and everything is actually tightened because they know that if it gets rough, things can fall. And when we went inside, he was holding a big instrument because there was nobody to help him. And in fact, he's from Vizag. So he's now retired. And so things can go very bad in very short time. For next 2 days, we had no food because you cannot cook on the ship if the ship is pitching and rolling. It was that rough. I landed in Orissa, so our ship was supposed to dock there. I went to Goa. Within 2 days, that everything, because of the cyclone, everything got flooded. And we see trawlers from the sea. It went into the paddy fields. And a lot of, in fact, people died during that cyclone. So we were really fortunate. And what happens, that kind of experience, and especially if you stay for long on the ship, because it pitches and rolls. Even when you sleep, even in your sleep, you will pitch and roll. And when you get down on the land, you also start walking like this for quite some time. It's a good scene to see. And what I realized, of course, that's a fun part of it. What I realized is how stable the land is, how important it is to be on the land. If we were to stay in the sea, it would be completely different. And I realized that it gave us that experience, meaning how important it is to be something that is very, very stable. That means the planet surface. And so that was quite a good experience. And I was going through the profile of this university. Very true. We may forego material benefits of civilization, but we cannot forego our right and opportunity to reap the benefits of education to the fullest extent. My experience in US, in fact, so how come then many developed countries, they became developed? What was the reason? And especially given their academic institutions. So if you see now, some of the top universities are from developed countries, right? And especially from US. So how different they are from our institutions in India. One thing is they are very, very large universities. They offer multidisciplinary education. That means they also get a lot of scholars from around the world. This is true in any top universities in the world, right? Now, where did they get this model from? To have very large universities, to have multidisciplinary education, and to invite international scholars. That means scholars from around the world. They must have gotten this model from somewhere. And when we look back about 400 to 500 years ago, same thing was happening in Baghdad. Baghdad was also at one point of time, it was called Center of Excellence. That means they invited scholars from around the world. And in fact, they rewarded anybody who used to come up with a new idea, anybody who used to bring literature from anywhere else in the world, they used to reward them. And so it went for a while. So that was a Center of Excellence during that time. Now, if we go back a little bit further, about 500 years prior to that, about 1200 BCE, then we had universities like Nalanda and Takshashila. Nalanda, in single campus itself, there were about 10,000 students in disciplines like Buddhism, yoga, art of war, astronomy, mathematics. And these are the places where people like Brahmagupta, Aryabhatta came from. Multidisciplinary, large universities inviting scholars from all around the world. And so there is no doubt that we have institutions like this, we cannot reach to the level where we are supposed to. And so this is exactly what it means to have universities like B.R. Ambedkar Open University. That means giving access, not just access, but access to quality education. And that I really feel that once we make sure that we give access to quality education, there is no excuse, there is no reason why we cannot attain those standards. All right, so I would like to ask now this question to this audience. Who would like to volunteer to go to Mars? I'm not talking about chocolate, but I'm talking about other planet Mars. Anybody would like to volunteer to go to Mars? Okay, few hands, very interesting. Few hands. So I asked this question, I gave a lecture just 2 weeks back to high school students. And we were just discussing as a part of celebration of Science Day, we had a 1.5 month celebration from January 15 to 28 February. What we did is we invited scientists from research institution and asked them to give lectures, exhibition to university. We invited university faculty to go and deliver lectures in colleges. And we asked college faculty to go and deliver talks, exhibition to schools and higher secondary students. And so we addressed about 35,000 students and we delivered lecture about 270 within 1.5 months. And so I was giving part of this called Vijnan Dhara, under which we did all these events. And I was giving a lecture to high school students. And so this was a stargazing program, given my background. And these students were from, high school, 5th standard, 6th standard, up to 10th standard. I asked the same question. There were about 200 students along with their parents who would like to volunteer to go to Mars. Everybody raised their hand. Everybody. And of course, they are very naive. They are still creative. So then I told them, okay, this is very good. It's very interesting. And now the only problem is, at present, we have the technology to go to Mars. However, we don't have the technology to come back. So even if you are able to go there, you may not be able to come back because we don't have the refueling station on Mars. We need fuel to come back, right? So then I asked, so now you tell me how many will volunteer to go to Mars? Good. Same question when I asked there, again, everybody raised their hand.
Oh, nice.
Except parents. Okay, that was still okay. Then I told them, even if you go there and you want to settle there. Now the problem is we need a lot of oxygen. And for our survival as humans, we need oxygen, right? Now the problem is we do not have appropriate amount of oxygen on Mars, for sure. And so the problem is we have to carry the oxygen cylinder on our back for around the clock. That means the entire day. Even when you sleep, you still have to carry. One student got up and he told me, sir, on Mars, the gravity is so low, it will not weigh too much. So no problem. And this was a 6th standard student. I was really impressed. I mean, that kind of creativity, we were all students at some point, right? High school student. So what happened to us? That kind of creativity, there is a nice definition of innovators. Dr. Raghunath Mashelkar mentioned this. An innovator is someone who do not know that it cannot be done. And so these are the students who really do not know. They don't care. They will ask questions. They will also tell the answers. However, what happened? We were the same students with same curiosity, same kind of innovative mind. What happened coming from high school to here? Something must have happened, right? We are a little bit scared to raise our hand. So something for sure must have happened, either in the system, educational system, or in society. So what is that thing has happened to us? So one thing is for sure, when we go to the classroom as a faculty, as a student, when we listen to the faculty, and also as an individual. So at least a couple of things that must have happened. And also, are there solutions? Can we do something about this? So let me ask you a question. Everybody has seen sunrise and sunset. Okay, that is good. So sun looks reddish or orangish during sunset, right? Now let me ask you a question. Why sun looks red color or orange color during sunset?
Light gets scattered. Lights get scattered.
Okay. Now, whoever has not answered, just raise your hand. I want somebody from maybe botany Is there any student from botany?
There are.
Just raise. Don't worry. Don't worry. I want student from botany or zoology, botany. Don't worry. Okay. So I will choose one student from botany. Can you stand? No, don't worry about it. So I'm not going to ask you any specific question. Yeah. You are from your discipline? Huh?
Botany, zoology.
Botany, zoology. Okay. Sorry, I do not know the nomenclature. Botany, zoology. Okay. Now somebody said here something to the response to the question I asked. Can you tell me why sun looks red color during sunset?
It may be due to the.
No. Did you hear what they told? Yeah. Can you tell? Can you just repeat?
Right.
Okay. Thank you, madam. Please sit down. So now, did you realize what has happened here? I asked the question, why sun looks red or sunset is reddish or orangish? Madam told the answer, sir told the answer. And then that's the same answer is also told by other people. Specifically, the reason why I asked from people from, not from physics or not from chemistry, there is a very specific reason. So everybody will else, other than the faculty, will also repeat the same answer. Now, you remember the scattering, right? You remember the scattering. So what we are trying to do also, and in fact, if you were to give a more detailed answer, they will also remember a lot of these words. This is happening because of scattering. This is happening because of interference, or that is. So you will remember all these words. And if I ask the same questions in the exams, you will try to put all those words in some language, which it may not make sense. However, you remember the words. You understood now what is happening? So this is exactly what is happening in most of our education system is we will try to remember the words. Now, we really may not understand what exactly scattering is. However, we will remember the words. Scattering, interference, absorption, transmission, those kind of words. And we will try to put all those words in our answers so that we get marks. And most of the time, that is what happens. And so now, of course, scattering, that happens. So let me also tell you now, you must have seen sunrise and sunset, and during this time, sun also looks bigger, right? How many of you have seen either sun or also moon? This is also true for moon. They look bigger if they are very close to the horizon, correct? If you take picture during the same time, so I took a picture of moon rising during the horizon, which actually looks bigger to us. And if we compare after 2 hours or 3 hours when moon or sun is very close to the zenith, and if we take picture and compare their sizes, they are exactly same. Although to us, they look much bigger. So what it also means that many times our sensors may not be very reliable. I just want to, this is of course, I mentioned this because we see this every day. However, we may not be seeing the reality. All right. Now, so what can we do? What can we do when we deliver lectures, when we deliver content, and we like to give some information? Now you would say scattering. So what happens when the light is scattered? We will give you, what would be the explanation? Sun consists of 7 colors, and majority of the lights get scattered, only red light remains. And that is why we see the color of the sun during sunset and sunrise as red. Okay. That also, if I tell you, you will still try to remember. And we can do that test using a prism. Now my question is, we do this experiment, we show them that there are 7 colors that are coming from sun. Are you really sure that 7 colors are coming from sun and not from prism? What is the guarantee that these colors, 7 colors, are not coming from prism, but from sun? You can ask that question, right? Because if I use any other torch also, single colored torch, but I can get also 7 colors if these colors are coming from prism. So that question we can also ask. So if you don't do this, then you are really just by-hearting the answers. Then how do we prove that those 7 colors are not coming from prism but they're coming from the sun? Then we have to do that experiment. We have to do that explanation. If we don't do that, that means we are just giving the information which students will really by heart. And so any statement I make, I have to really justify either by experiment or by any other things where it cannot be shown in terms of experiment. So that is what we should do. All right. So why we really by heart answers? Now, when we go out of the classroom, we really think that it is only meant for answering those questions because it will come in the examination. And when we go outside, we really forget about the sun, sunset, all those colors. Of course, when we look at the sunset, we enjoy it, but we never ask because it's the same sun which you have seen during the noontime above your head, but it looks mostly yellow or white in color, but it's the same sun. Then how does sun know that it has to change the color during evening time? It does not know, right? So something else must be happening, but we never ask those questions. So if you don't make that connection, and if it is not really relevant to them, they will always by heart those answers, and they will try to answer those questions. Of course, they will get good grades, but it is not that they have understood. It may be that most of the time they have just by-hearted. They only know scattering, interference, reflection, and those kind of words. So let me ask you now another question. And somebody can volunteer. If somebody wants to volunteer, I want their age. Go ahead. Stand up. Yeah. Tell me your age. If you are not worried telling, 21. Nice. Thank you, ma'am. Thank you, ma'am. Sit down. So we have students in this room now, maybe from age of 20 to up to, 55, 60. Okay. So how do you know that you are 21 years old? How do you know? I'm just asking, just a regular question. How do you know that you are 21 years old? Date of birth. Very nice. Date of birth. So you are 21 years old. If there are any microbiology, biology students from in here, from those disciplines, we really know that our body cells, they die and new cells are born. They are replaced by new cells every day. And on an average, every 3 months, or most of the cells are replaced. That means we have new cells every 3 months. In fact, essentially, every 3 months, we are born again. This is really interesting, every 3 months. Now, suppose say we are a new person every 3 months. Then how do you remember something that has happened before 3 months? If we are born every 3 months, if all our cells gets replaced every 3 months, and this is true, this is not just theoretical thing that I'm telling. Every 3 months, if we are reborn, then how do we remember something that has happened last year, 5 years back, 10 years back? Interesting question, right? So now don't go and tell your wife or husband that you are 3 months old. You know what will be their response? I knew that you are 3 months old because based on your behavior. But that is true. That is true. So every 3 months on an average, all our cells get replaced. Very interesting. I mean, it's difficult to fathom, how this thing can happen. Still, we remember everything that has happened, not just last year, 10 years back, even during our childhood. Okay, so you may be 21 years old. Now I told you you are 3 months old. So another question, maybe from people from geography side. Now, if I ask you the question, what is the composition of Earth? That means I'm asking, what is the elemental abundance? How much water is present on Earth? Percentage-wise. About 65, 70%. Everybody agrees? 70%. Okay, very close to 70, 75%. All right. And then there are, of course, other elements. For example, so now water is there, but that means H2O, hydrogen and oxygen, but also there is carbon, nitrogen in atmosphere, right? Now, what about human body composition? So very close to about 65% or very close to 70%. Now, this is just again water. So that means hydrogen or oxygen. But also if you look at other elements, that means nitrogen and other elements that are present in very small quantity, that percentage is also similar. So in human body, it's close to about 70%. And on the planet, it's also very close to about 70%. And also this is true for other elements. That means hydrogen, oxygen, carbon, nitrogen, and oxygen. Percentage-wise, it's similar. So this may be a coincidence that it is same proportion on the Earth and in the body. Now, if we look in universe, it is also the same percentage. Hydrogen, most abundant, and then there is, of course, helium, but it's an inert gas, we don't use it. And then we have carbon, nitrogen, and oxygen. So now my question is, all these three places, human, Earth, and universe, is it a coincidence? Is it by accident? Or is there something else that is happening? That means if it is not a coincidence, somebody has to pass this information from universe to bring everything onto the Earth in same proportion, and then from the Earth to the human body. Now, who is that someone? Let me ask this question to people from maybe biology, zoology, botany.
Nature.
Huh?
Nature.
Nature, but nature itself is, Earth itself is nature, right? Universe itself is nature. That means somebody has to put this information that on the Earth, we have 70% of water. That means also in human body, we should have 70% water. That means hydrogen, mostly hydrogen is the most abundant. And universe, that is also true. Then how come we got the same amount of hydrogen in our body, oxygen in our body, nitrogen in our body?
Maybe a prototype of that, can we consider that we are prototype?
Prototype, okay.
Since during the evolution, the water was abundant, sir. So maybe we can say that water is abundant. So hydrogen consisting of water.
Correct.
So it used it.
Correct. What used it? Meaning I was not born in the soil, right? I was not born in the soil. So somebody has to put this information, right? That means this much hydrogen should be there, this much carbon. But this is really interesting. Now, of course, it is interesting for students from sciences. What about common man? Now, I asked very specifically that who is that someone?
We evolved over a period of time because we come from, nano to this level. Maybe.
Correct. So what Madam says is that we evolved, and then we evolved from very small things to bigger things. But again, I was not born in the soil. Somebody has to put that information from planet, that means from the soil, that this is the composition of Earth. Now it has to put that information in that nano thing where we evolved from, right? And so for general public, now the bigger question, where I'm going to is the bigger question. Again, you can ask, Who is that somebody? Is it now we really require God to put this information from soil to human beings, from universe to the planet?
Yes, nature itself made it. We are able.
Who is that nature?
It's
now?
all about 5 elements. So we started with that.
Yeah, I understood, ma'am. So my question is now, see, now you are trying to explain what must have happened. Correct? Yeah. So
over a period of time, it happened.
Yeah, but somebody has to put that information. That is you understood my question?
Carrying agent.
Carrying agent, correct? So now for a biologist, for a person from sciences, you will of course try to explain this using given evidences, using given observations. But some people will also require God. You cannot just take hydrogen from universe, put it on the earth, and then take again same amount of hydrogen, then put it in the human being. I'm not really looking for an answer. I'm just putting a question.
That's the reason we started religion for the cause of human beings to have faith. So that maybe.
Yeah, I do not really know. But so this is what is happening. So if we really don't show that relevance, if we are not able to connect what is happening in the classroom to the outside world where actually we are living, we will again try to just remember the words. So here I'm also not looking for an answer. So I'm just posing that question. So it gets very interesting now. So in terms of abundance, this is the abundance we have for elements. That means hydrogen is the most abundant, and that is true in the universe. Now, what is very interesting is this. So hydrogen, although it is available for us in atmosphere, it is not really produced on the earth, or it is neither produced in our body. The only place, except only on few occasions, the only place where hydrogen can be produced is during the birth of the universe. That means even in the stars, hydrogen is not produced, meaning hydrogen is it's the lightest element. Then we have only proton and we have electron. They combine to form the simplest element that we call hydrogen. And that happened only during the what we call now Big Bang, the birth of the universe, right? Now, same hydrogen went into the stars. Same hydrogen came to form a lot of planets like Earth, and same hydrogen entered in our bodies. Whatever way it came. Now, if we really measure our age using hydrogen, how old you will be?
Universe.
How old you will be?
Yeah,
from 3 months to beginning of the universe. And the age of the universe today is about 13 billion years. 13 billion years. I told you you were 3 months old, right? Now, if you really consider the age of that hydrogen which is present in our body, it is really 13 billion years old. And then, of course, if we die, that hydrogen still remains. It goes somewhere else. It may go in other person. It may go onto another planet. It may go in space. It may go in another stars to form new stars. And that really, that connection from one person to another, from one planet to another, from one star to another, it's the same hydrogen. And so it depends how we measure our age. It depends how we are able to relate to somebody else. But it's the same hydrogen. I take oxygen in, then I give also out some other gases. But all those elements are always present in the universe, and we share the same elements. And so why same abundance in humans? It's simply because, it has come from the universe. And I just mentioned this. So it depends on how we measure our age. Now, just to put another quick question, especially for faculty and students from chemistry. Why gold is expensive?
The process is very tough, sir. And you can ask one more question also, why diamonds are very expensive?
Because diamonds are forever.
Yeah.
Diamonds are forever, right? Why gold is that expensive? It is because mostly it is rare. And of course, we like it. We like it to wear, but it is also rare. Why it is rare? Why it is not in the same amount as iron? That means somebody who was manufacturing iron did not make same amount of gold, right? In the universe, somebody who was manufacturing or when he was sharing iron, he did not make same amount of gold and diamond for that matter. I will not tell you the answer. This is very interesting. It is not a coincidence why we have different amount of iron, why we have different amount of gold, why we have different amount of diamonds, means carbon mostly. It is very interesting. You might think that answers to this you will get in chemistry, but you will not. You will not. So if you look at the periodic table, you can tell all the elements are not present in the same percentage. They have different percentage. I will just give you the hint. By the way, although we have iron, that means we can find iron inside the earth. That means on the earth, we cannot make iron on the earth. We cannot make iron on the earth. Now you can try to find out the answer somewhere else. So it is very interesting, right? All right. Now coming very general questions. Very general. Why 12 months a year? If you were given the responsibility to make a calendar today, you would not come out with this number 12. You can make maybe 10 months is easier to remember. Maybe I will make it 20 months, maybe 50 months. But why 12 months a year?
It takes 12 months to cover the path.
Okay. If you were to make that calendar, you can also make it 10 months. Make 1 month longer, but you can make 10 months, right? So instead of 30 days a month, you can make it 40 days a month or 35 days a month. So instead of 12 months, you can make it 10 months. And then we'll say it takes 10 months for Earth to revolve around the sun.
It is because the moon revolves around the earth takes 30 days. Exactly.
Okay. So
So there are 30 days in a month. Like that we can see.
why? That was my next question. Why 30 days? If I were to given the responsibility to make calendar, I would make it only 10 days a month or maybe 50 days a month. Why? But why 30, 31, 28 days?
So the moon
I'm just asking. If you are given the responsibility, this gets very interesting because we use a lot of things. Now, these are all designed based on what we saw during that time. That means in the sky, and which were all reliable. Now, I will ask you a very personal question. Maybe if somebody can volunteer. We have heard of Rashi, zodiac sign. Anybody born in March? Anybody born in March? Don't worry, I will not ask for your cake, birthday celebration. Don't worry. No, I'm just asking because we know that there are 12 Rashis. Now you will say that because there are 12 Rashis, there are 12 months. Correct? Then why there are only 12 Rashis? I'm just asking the question. Now, those Rashis, of course, we can name as all, maybe in March, Capricorn or Pisces, it depends. So we have two kinds of Rashis. One is called sun sign, one is called moon sign or star sign, right? So it gets very interesting. Now I will show you. Let me just see. Why 12 months a year? And then why 30 days a month on an average? So this is exactly what a Rashi means. That means these are all stars in the sky, but many of the bright stars, sometimes they look like some figure. Now, in this case, a Leo, that means a lion, all those stars form, and what in English we call, they are all constellation. So this looks like a lion, so it has been named as Leo. And so that's the whole idea. So anything, whatever it looks like a figure, we will name it. So they were all named in ancient times according to what they look like. This is Gemini, right? Mithun. So you can see all those bright stars, they look like, meaning two females or a couple. And so they were named, what they appeared to be. Now, many of you have that sun sign, star sign, birth sign. What it really means, now I know many of you also have Kundali. I can tell also your future, right? What it really means when you were born, what it means, what is done in astrology, what it means is that when you were born, where was the sun in the sky? In fact, in the sky, these are only 12 that we considered, but there are also other rashis. There are also other constellations. Altogether, about 86 constellations are there. However, we consider only 12 rashis. That means only 12 constellations. These are called only 12 zodiac constellations, because where the sun rises and where the sun sets, there are only these 12 constellations which it passes through. Sun, moon, and all other planets passes through these 12 constellations. And that's why these are 12 rashis. Otherwise, there are also other rashis which does not fall along this east-west belt. That's what we call zodiac, right? And so now I will tell you why 12 months and why 30 days in a month particularly. So what happens is this. Sun, at least for us, it will appear to move from east to west. And at the same time, in the sky, it will move from one constellation to another constellation. And it remains in one constellation for about a month. That means for 30 days. That means it moves from one constellation to another every 30, 31 days. And for that reason, every month has either on an average about 30 days. Not that somebody liked that 30 number. And why 12 months? Again, those 12 constellations are there in that zodiac belt. So all the calendars, why they were made based on these astronomical, you can say astronomical objects in the sky, mostly in the stars, is that they will be there for a long, long time. If we make any artificial instrument on the earth, it may not be there for a long time, but these will be there for a long, long time. And they're there for quite some time now. They are the same stars, they don't move much, and they are there in the same pattern. And that's the reason why they are there. All right, so sun rises in the east. How many of you know sun rises in the east? Everybody knows. That's why nobody is raising their hand, right? Okay. So let me just show you whether it really rises in the east. So this is a computer simulation. That means what I can do is I can simulate a sky where the sun rises, how it sets, where it is today, where it is at any given point of time. So here is the ground and here is the east that is marked. In fact, I can also move it. For example, I can go to west. Just see. So it will also show me. So this is northwest. Yeah. And also this is west. You can see here west. And I can also move that. Now, here I can choose any time to see where the sun is. Right? I'll just go back towards east. This is quite a fantastic piece of software. Okay, yeah. So this is east. So let me change the time. I can also change the time. Okay. So here I can change the time and all right, here. Sharing. Just share the screen. Yeah, okay. Yeah. This will take a few minutes, but this gets very interesting. So what I can do is, okay, what I can do is I can change the time. You can see. I can make it 8:30 and where the sun is, right? Now, what is the date today? 6th March. So sun rises very close to east side. Now what I will do is, so in fact, what I can just simulate. So I can just increase the time, then it will be night time, then everything will happen. Tomorrow again, the sun will rise. So I can run the clock either forward or also backward. Okay, I can do that here. Now what I will do is, so today is 6, I can change the time, and so this is at 7:30. I will just make it 8 o'clock. I can also change the date. So instead of 6, what I will do is make it 7, 8, and you can see sun at the same time, sun is not rising in the same place. You can see. I don't know if you have seen this, only if you get up in the morning. Now what you will see is that sun went that side. Now again it is moving this side. So instead of days, now what I will do is I will just increase it by month. So you can see the movement of sun. You see what is happening now? Okay. In fact, it is not really rising in the east, except one day. It is rising either in the northwest or northeast. Or we can say it is in fact rising in the north side or south side. Except on March 22nd, I will just make it March 22nd here. Okay. And only during that time, it is rising very close to the east. Every other day, it is not rising in the east. Now, what it also means is that here, what I will do is, now it has gone to the north side. On June 22nd, it will start coming to again the south side. And that is when we call Dakshinayan. Have you heard of Uttarayan and Dakshinayan? Okay. That is when it is called. When is Uttarayan?
15th January.
No, Uttarayan. Makar Sankranti, okay? I will come. I knew that I will get this answer. But Uttarayan, or what we call winter solstice, is really happening on December 22nd. December 22nd. Uttarayan. That means, so I will make it December here. Okay. And December 22nd. So that is the day when sun will start now moving towards north. That means Uttar, right? Okay. Now, I will come back here. Okay. Share the screen. Yeah. So my question is now, this gets very interesting because Makar Sankranti is on 14th January, but Uttarayan is on 22nd December. Then why we call Makar Sankranti also Uttarayan?
It starts from that day. It starts from that day.
Yeah, so Uttarayan starts on 22nd December, but in some states it is also called, on Makar Sankranti we also call Uttarayan. But actually Uttarayan happens on 22nd December, not on 14th January. Now, you know why it is called Makar Sankranti? Why? Not because you distribute Tilgur. Why it is called Makar Sankranti? What is Makar? Huh? Makar Rashi. That's Capricorn.
Stars will change the positions. Stars will change the positions and they transfer from one place to the other.
Yeah.
They enter into the other.
So on Makar Sankranti, that is exactly on 15th January, sun enters Makar Rashi. Sun enters that Makar Rashi, which I showed you. If I show you that computer simulation on 15 January, sun will go from another constellation to Makar constellation. And that's why that happens every year on 14 January or maybe on 15 January. But that is when the sun enters that Rashi. And that's why it is called Makar Rashi. But how come it is also called Uttarayan in some state? It does not happen on 22nd December. Now it gets very interesting. Now I can use that same computer's simulation. How come people got confused to name Makar Sankranti as Uttarayan when it is not? What it means is that at some point of time, Makar Sankranti and Uttarayan was on the same day. That means on 22nd December itself, sometime back, sun entered Makar Rashi. And they were on the same day. And if we run that computer simulation, I can also show you that happened about 1,700 years ago. That means sun entered Makar Rashi on 22nd December instead of January 14. And that's why it is called. So if we consider that, that means Makar Sankranti or what we call Uttarayan, these festivals are at least 1,700 years old. So we can use astronomical data to even tell how old are our festivals, or given any of those kind of incidents that have happened in the past. Quite accurate, quite fascinating. So let me just now quickly, for last few minutes, I will just show you about what I do as part of my research. Everybody has seen the night sky. Is there anyone who has not seen the night sky? What do you see? Stars, of course. Now, if I give you a binocular or small telescope, and if I ask you to look at the small portion of the night sky, what do you expect to see? Of course, in naked eye, we can see stars, right? But if I give you a small telescope, what do you expect to see?
Constellation. Constellation.
Constellation, of course, we can see even with naked eye. But if I give you a small telescope, binocular, this is what you will see. They are all stars. Of course, these are all in sky, that means in space, but they are all stars. Now, if I give you even a bigger telescope and maybe ask to zoom in small part of that part of the sky. Now, what do you expect to see? These are all stars. Whatever you see here, they are all stars, just like our sun. Now, if with a bigger telescope, what do you expect to see? This is what you see. Now, none of these are stars, but they are all galaxies. That means every single thing what you see in this image is a galaxy, and galaxy consists of so many stars, sun-like stars. Okay. Now, if I give you Hubble Space Telescope or even bigger telescope, and we do the same thing again, we zoom in small part of that sky. Now, what do you expect to see? Again, the galaxy. So we see even more galaxies. And so now the question is, how big is the universe? In fact, what I shown you here is a very small part of the sky. It is not even the entire sky, but if you compare to the size of moon, it is only about 10% of the size of the moon. It is not even the entire sky. So you can imagine how big is the universe. So I just want to give you the idea, because my interest in research now is how really it started all, and what was there in the beginning of the universe when universe was started. So just to give you the idea, this is the actual video footage of our sun. So if we compare Earth to the size of the sun, just to give you the scale. So what you see here, sun is of course made of hot hydrogen gas. And a lot of times this hydrogen gas will go in space. Again, it will fall back, and these are all what we call flares or coronal ejection. It goes into the space. Can I just put what happens is this, why this is happening is because it uses a lot of power when we do the that software, when you do that simulation. Thank you. Perfect. So this is the sun. Now, how big is the Earth compared to the sun? So if we just take the snapshot of that, and you can see that coronal loop, that is the Earth. Do you see? Very small. And so now, as VC sir was mentioning, how big we are really in this entire universe? Very, very minuscule. You know, even those kind of flares, if it reaches to Earth, it can actually wipe out the entire Earth within no time. Okay. So in fact, this is the same image I took with the same telescope. Now, what you see here, the dark spot, they are called sunspots. And sometimes the size of what happens is this on the sun. All the gas that is there on the surface of the sun, it goes inside, nothing comes out. Similar to black holes. Of course, these are not black holes, but light cannot come outside this sunspot, this dark spot. But these dark spots, these sunspots sometimes are so big, if we compare to the size of this, I captured to the same telescope, what we have. Even those dark spots on the sun are much, much bigger than the size of the Earth. They're very, very big. And so you can compare now how big we are. So if we compare the size of sun to size of our own Milky Way galaxy, what we call Akash Ganga. Akash Ganga, that means Milky Way consists of so many sun-like stars. And sun will be another dot in that Milky Way galaxy. And how many stars are there in this galaxy? That's about 200 billion sun-like stars in one galaxy. How many galaxies are there? Of planets in the entire universe? Is it high or is it very low? It's quite high, it looks like. But of course, we have not found anything simply because it is too big. In our solar system, we have only about 8 or 9 planets.
Not able to reach.
We are not able to reach because it's too big. It's dark, but we can have flashlights. Right. So it gets very interesting because now what happens is that is what exactly we wanted to find out. What was there in the beginning of the universe and what kind of chemicals, whether the environment was okay for life to form. That means life to exist. And so that was part of my research to find out how many galaxies were there in the beginning and when did the first galaxies form in the universe. That means about 13 billion years ago. Now, one interesting thing that happens in astronomy is this. Sun is quite far from our sun, which is there in our solar system. Even for light, it takes about 8 minutes to reach from sun to the earth. So suppose say now sun shuts down. That means if somebody switches off the sun, we will know only after about 8 minutes because that information we will get only after about 8 minutes. The next closest star to us other than the sun is about 4 light years away. If your friend stays near that star, and if they celebrate their birthday, we will know only after about 4 years. Because that information in the form of light will reach only after about 4 years. That means if there is any other galaxies that is 100 light years away from us, and again your relatives stay there, we will know that they are celebrating only after about 100 years because that light will take about 100 years to reach us from that galaxy to us. So if we want to know anything that has happened in the past, the best way to do is find out what is the farthest thing from us, because that information is reaching us now. And so the idea was to discover galaxies that are very, very far, very, very far. So far that they are exactly close to the age of the universe. That means if we discover something that is same as the age of the universe, let's say one galaxy that is 13 billion years old, and we know that age of our universe is also 13 billion years old, we can get that information now, how the condition were 13 billion years ago. Fantastic. This is only possible in astronomy. So we were trying to discover that galaxies which are about 13 billion light years away from us, because we can now see what was there 13 billion years ago when universe was formed. And so we did a large astronomy survey to identify galaxies that are very, very far. And we discovered one galaxy which we made world record in 2013. We discovered one galaxy. We had to really search for about 200,000 galaxies, out of which we found only one galaxy that was 13 billion light years away. Of course, it took about 7 years, and Hubble Space Telescope, and about 180 people from around the world. So we had a big collaboration, a lot of experts. This required a lot of expertise, and we made use of that. And we had to use a Hubble Space Telescope that is really in space. Now, the advantage in space is that it doesn't rain there, no clouds, so we can do the observation 365 days a year. And so that's the advantage. And the images we get, they are all crystal clear because there is no light pollution, no aberration from the atmosphere. And some of our team members, now these also we had to use some special instrument in the telescope. These two telescopes are on Earth in Hawaii on an island at the height of about 15,000 feet. The reason why we want to go to higher elevation is that there is no atmosphere. In fact, if we see there, they are so high that you can see the clouds are even below compared to the telescope. These are two telescopes. And the temperatures there is about -5, -10 degrees outside. And what happens to the oxygen level when you go at higher elevation? It decreases. Now, if there is no oxygen, what happens to your brain? It does not function. And in fact, when we go here, we cannot work there continuously. We can work only for about 7 to 8 hours. Then we have to come back down, stay there, and then go next day. Now, one funny thing happens there when you go to higher level of elevation and when there is low level of oxygen. Although you might think that everything works fine, your brain works properly, we have to write down all the instructions, what we'll do step by step. And we just follow those same instructions. Otherwise, what happens? You work the entire night, you take all the data, and then next morning you realize that you did not open the telescope cover. Although you think everything works fine. And there is something called hallucination that happens at this kind of elevation because of lack of oxygen. And so those kind of experiences, either in the sea or on the mountains, you can get in extreme environment. So we discovered that 13 billion years, light years far away galaxy. Now, what was very interesting is this. Now, our own Milky Way galaxy produces one new star every year. It is very interesting. That means if you look in the sky, if we are able to see all the sky, next year there will be one new star in the sky. Every year, it makes about one new star every year. What interesting, what we found in this galaxy is, this galaxy is making about 300 new stars every year. That means if we were in this galaxy, we would see 300 new stars every year. Very fascinating. And this was the first time we discovered a galaxy so bright. That means 300 new stars every year. It is really, really bright compared to our own Milky Way galaxy. And the other discovery that we made, what Madam mentioned, is that it is not just the 300 new stars, but the center of this galaxy also contains a black hole. Now, of course, to make a black hole, you really require a lot of stuff. That means for making a black hole, you really require a lot of things because it has a very strong gravitational force. And to make that strong gravitational force, you require a lot of mass. And you have to put a lot of stars, you have to put a lot of mass together. Only then we can have black holes. And what we discovered is that at the center of that galaxy, it contains also a black hole. So this is the first time anybody has seen a black hole at the center of a galaxy and during the birth of the universe itself. So this was in 2017. And in 2020, what we discovered is that what we used to think that in the beginning of the universe, about 13 billion years ago, there are only few galaxies. And these galaxies are all sort of isolated. What we found for the first time that there are quite a few places where galaxies, like people, galaxies also would like to stay together. So we found one galaxy group. Of course, this is an artist rendition, but they look very small. And in 2020, we made this record of finding the most distant group of galaxies. That means what it also means is that this is the first group of galaxies we discovered in the universe that must have formed. And so it is really fascinating that, you know, someone like me who grew up in a village, given the right environment, given the right settings, we can do quite a lot of things. Just 3 weeks back, we had a comet in the sky, and in entire India, we captured, this is the closest approach of comet to the planet Mars, and we captured that in Goa. So it came in Times of India. Now, this comet is very fascinating. Why it is really fascinating that this happens only once in 50,000 years. That means this comet came very close to the sun, and now it is moving away from the sun. And you know what is the speed at which it is moving? 2 lakh kilometers per hour. What is the speed of your car or scooter? 60 kilometers per hour. This is moving at 2 lakh kilometers per hour speed. You cannot even imagine. And so this was the closest approach to Mars. So we captured that, and we captured that in the form of a video. You can see what you see in the background. They are all stars in the sky, but this comet, of course, it looks slower here, but in reality, it is moving at about 2 lakh kilometers per hour speed. And so you can see that comet moving and so fast. Now, why those are very interesting is that, why comets are very interesting. The reason is that, so one of the models we have now is that why did life came into existence on Earth is because, so one of the supported theories is that a lot of water might have come from the comets, because comets compose mostly of ice, and that they leave behind all this material, and might be that a lot of ice might have come from this kind of comet. And so if it is true that we actually might have originated from comet itself, because that water came from the comet. And so it gets very interesting. Finally, just a couple of slides before I stop. So what it feels like discovering new things, what it feels like when you invent something new, because when we discovered that galaxy, when we discovered the black hole, we are the first people in the entire world to see it for the first time. And maybe if there is no life on any other planet, we might be the first people in the entire universe to see those galaxies for the first time. So what it feels like.
Pretty amazing. Charlie.
So this is what it really feels like. See, you are the first one maybe in the entire world, no, if not in the entire world, maybe in the entire universe to see those kind of things. And I will conclude now by saying that India also has a lot of mission. In fact, this was supposed to happen in 2022. Now it is planned for 2024. Already a lot of things are happening. So India will have a Gaganyaan, that means a space mission where astronauts will be able to go and stay in the space, do a lot of experiments, and then come back. So under Gaganyaan, we will have our Indian astronauts go in space, stay there for 1 week, do the experiments, and come back. Already there is an international space station where US, Europe, Canada, and Japan are participating, where astronauts can go in space and do the experiments. So a lot of things has been happening. I will just show you what it is like to go in space and do the experiments and work there. What we will gain, what we are missing by not doing it. So I will just play a video of this lady astronaut who is in the International Space Station. That means that station is in space where astronauts go there and do the experiment. So I will just play a video. You watch it carefully. So it's a
brand new bag of water, and so my straw was a little crimped there. And I'm going to come a little closer, and you can see this giant blob of water. And we're getting to see in space, what do liquids really, really want to do?
Wow. That is amazing. That is amazing. So I'm curious, because I know you have kids at home. How do you stay close to your kids? Oh, wow.
So this is how you drink water in space. Any volunteers to go there? Did you look at her hair? What happens? Okay. Now suppose say you are trying to take shower in the morning. Water will not fall, right? Because now there is nothing like falling. Now what happens on the International Space Station? You do not feel that gravity. You don't feel, there is gravity, but you do not feel that gravity. So if you are trying to take a shower, normal shower, you will not be able to take. Nothing will come out of the shower. You have to really catch those water bubbles and then you can use your own expertise. So what I'm trying to say is that things which are very, very easy on the Earth becomes very, very complicated in the space. And we can do a lot of experiments, meaning how fast plants can grow in space, a lot of other things. And before I end, I will just show you what happens when we stay in the space and then when we come back. So this is one of the astronauts who was in space station. Now he came back to the Earth.
No feeling afraid.
So that is what happens when you come back on the Earth. Why?
What you should understand.
Right. So as I was mentioning, when you get down from the ship, you get used to that pitching and rolling. Also that happens in space. When you stay there, because of gravity, we feel that here on the Earth. We are okay. Without getting drunk, we can walk okay. But in space, what happens is this. You don't feel that gravity. And so without that gravity, your bones will also grow weaker. And then because there is no gravity, we will not have that strength. Because there is nothing like on the ground, up and down. You are all the time floating. When you come back, you have to really get trained, even for walking, even for sleeping. And so now we can do the experiments. Can some diseases be cured in space much faster? Because now you don't have gravity. Can some plants grow much faster without gravity? And a lot of other things. And so if you don't do those kind of experiments, we really miss out on a lot of things, a lot of experiment. So I will stop here, and my apologies for taking more time, but this gets interesting. And thank you very much.
He wants to ask some
A question now.
only.
Yes. I am open. I am free to take any questions. It's
So the sunrise and sunset timings, like which we are predicting now with the simulation and all, how was it possible some thousands of years ago, and how accurate they are today, if we find in the Panchangas and all?
Okay. She's asking about her future.
No, not future.
Understood.
The previous ones, how accurate they are in the current times,
Correct.
and how was it possible then, thousands of years back?
So right now, it is very, very accurate. What we predict, I'm not talking about Panchang, but the predictions I showed in this software is quite accurate. We can precisely tell when will be the eclipse, when will be the next solar eclipse, when will be the next full eclipse, when will be the next lunar eclipse, so that we can predict accurately, because now we know the positions of stars, positions of all the planets, and based on our understanding of physics, we can precisely tell when these things will happen in the sky. What about in the ancient times? Whether how accurate they were? In fact, they were also quite accurate. They were quite accurate because, in fact, we were discussing that in the morning. They had done a lot of observations of the sky. Lot meaning lot of observations. Now, even with the telescope, it takes me so much time to do observations. However, during that time, they did not have those kind of facilities. Of course, sky was much better. That means less light pollution, much darker sky. They could see a lot of stars, a lot of planets. And that's why we have only 7 days in a week, not 10 days or not 5 days. They could see the movements of planets. Although for us, they all appear like stars, but that time they had realized that these are all planets. That's why only 7 days a week. So what the observations they had done for quite a long time is, I cannot even imagine how much time they must have spent. So as per the sunrise, sun timings, now, once you do it for a few years, you will get quite good, accurate model of how things work in the sky. That means a model of the universe. Of course, that doesn't mean that they will be right all 100% of the time. We know that Earth, at one point, we considered Earth at the center of our solar system. However, it is not true. But they could make good predictions. At least as far as the timings are concerned, they could make a good prediction based on their observations.
So now, low-level satellite internet has been achieved by Starlink, and more on the way. Like and BSNL, there is some data running with our government entities. How do these affect astronomy?
Yeah. So the question is, now we are launching a lot of satellites. Either geostationary satellites or even polar satellites, low Earth orbit satellites. So his question is, if we launch too many satellites, whether it will block our view of the space. And the answer is, at some percentage, yes. However, what can we do? The only thing what can we do is, we really need to have space telescopes, or then we have to come out with some regulation so that we keep that to minimum number of satellites. That is the only solution. Otherwise, at least as of now, there are no regulations on launching of satellites and who can launch. For example, Elon Musk is launching so many satellites. ISRO is launching so many satellites. But at least as of now, there are no restrictions on that. But we can regulate that. So if we come with good policies, if we really want to understand what happens in the space and then what is really our place in this universe, we can come up with good regulations.
So imagine if there is a scenario like one of the satellites gets out of control.
Just a moment.
So, this scenario where one of the satellites collides with another, this leads to a chain reaction. So, it's totally complete. So, the space will be, the atmosphere will be so polluted that we cannot see outside. So, is there a way we can collect that debris from Earth? Is there any experimentation going on with that?
Yeah, definitely. So the question is, suppose say we launch a lot of satellites. In fact, right now there are so many satellites. It looks a trash in the space. So, and then, after a few years, they also go out of service. What do we do of these satellites? It's a problem. Now there are already projects that are designed to collect this, what we call space junk, and then either bring it down or reprocess it. Fortunately, what happens is, of course, now this is happening very close to the Earth. Now that is a problem for us. However, if we get a technology, universe is so huge that if we are able to get all this junk in the space, put it together and just throw out in the space, then no problem for us, because universe is so huge that it will not even affect anything, because there is so much space in between two stars, we will never be able to fill that space. Of course, this does not give us the right to trash space, but I'm just saying that is one of the ways. So we have to minimize the trash, we have to minimize that junk, but there are solutions, and there are already projects that are working towards getting the space junk either towards Earth or reprocess. That's a good question.
I have two questions, sir.
Yes, ma'am.
One is, how do you distinguish between galaxies? Even is the intergalactic space much bigger, or is it little actually? How do you distinguish one galaxy and another? How much is the intergalactic space? And the other question, recently there was a discovery of 6 major galaxies with massive what you call stars. So how does it having high density of stars different from galaxies having less density? Does it have any significance?
Yeah. So what ma'am asked is, how much is the space between two galaxies? So if we take the next closest galaxy to us, that means Milky Way, the next closest neighbor is the Andromeda galaxy. And the distance between Andromeda galaxy and Milky Way is about 2 million light years. That means from that galaxy to us, it will take, even for light, 2 million years. If you go to a remote place, and I have taken some pictures of that Andromeda galaxy using the same telescope, you can see that. So that is the distance. So they are quite far. Between two galaxies, the distance is quite far. And so most of the space is really empty between two galaxies. The second question was, there was a recent discovery that now few galaxies in the beginning of the universe, these galaxies also contain a lot of stars. And what we call is that they are quite big, much bigger than the stars like Sun. And those galaxies are also much bigger than our Milky Way galaxy. So what implication does it have for the research? Now, what happens to stars that are much more bigger in terms of mass? That means they are much massive. If they are massive, because of their own gravity, sometimes they collapse and then they form what we call stellar black holes. They can form black holes. That means we can have a lot of black holes if we have more number of massive stars. Now, if we have more number of massive galaxies, what it can do is, and what we find out now is that most of the galaxies have black holes at their centers. Their black holes will also be huge, what we are called stellar black holes. When they form from single star, we have massive black holes. They form at the center of galaxies. Now, if these galaxies are big, their black holes also will be bigger. And in fact, if we go very close to the center of our own Milky Way galaxy, we can see that a lot of stars are revolving around the black hole. And at some point, if they get too close, all these stars will fall inside that black hole. And you know what happens if you go inside the black hole or very close to the black hole. That is where you send your friend if you don't like them. They will not come back.
That is
supermassive black hole.
The one you have discovered in 2013. What you further go on actually we will have some very good. Yeah.
So in 2017, the galaxy we discovered, in fact, later on, what we found out is the black hole is at the center. Second one is that galaxy is producing about 300 new stars every year. We had never found such galaxy during beginning of the universe that is so bright. That means every year they are producing 300 new stars in the sky. And finally, what we another element what we found that also was not very common, that is also nitrogen. That galaxy also contains nitrogen, and now after that there were few other galaxies where other astronomers also found out that there is one kind of nitrogen that is present in those kind of galaxies. So that kind of element we had never seen before during the birth of the universe.
Hello, sir. Sir, sir, actually, I had a question. You said that sun will be residing, I mean, we'll see a constellation for about 30 days.
Yeah, correct.
But, you said I mean, only 12 months are there and every month is 30 days. But February has 20 days.
Partiality for February. I don't know the answer. You have to find out.
And one more question, sir. People are saying that we can't just like is January 1st is chosen by us, isn't it?
Very first, said sorry.
I mean, we chose a day and we just made it a January 1st.
January 1st as the first day. Okay.
So, like that, likewise, if we go there, month of February doesn't have that 30 days. So, sun won't lie in that. Sun will lie in that constellation.
So, do you know that if you take some Indian calendars, they also add another extra year after every few years? You know that? You are aware of that, right? Adhika Mas. It's called Adhika Mas. That is because the calendar was designed, meaning you have to make adjustment after a few years to make up for this. And that is why we add that additional month, what we call Adhik Mas. And so for February also, then we have to add another day every leap year.
29 days.
29 days. Right. Now we can give that responsibility to you, design that calendar, which will be very perfect. Yes, ma'am.
Yeah, final one, maybe.
Very final.
Yeah.
I will basic question. Asked us what is the guarantee of sustenance over there?
I cannot guarantee. It is that's why volunteers, no? It is your choice. I cannot guarantee anything. Not yet. We haven't found any water in liquid form on any of the planets. But still, you would like to volunteer? We would be very happy.
Yeah, take that mic. Babu.
Yeah, please.
No, hand over. Next person.
Sir, as you explained about prism that scatters the light, so if you pass through infrared light through the prism, what happens?
Anybody knows the answer?
Is the part of white light,
Anybody knows the answer? Yeah. So for any light, if you do these experiments, it will work. Now infrared, we will not infrared. So the question is, so we have the electromagnetic spectrum. Visible part of the spectrum is only a very small part of the spectrum, right? What we see through the naked eye is only a very small part of the spectrum. So his question is, what happens if we go to other part of the spectrum, what is called infrared. So there is also ultraviolet, there is also visible, and there is also infrared. What happens if you pass through the prism? Have you sat in your car with full AC and you get skin burns when there is sun? In the sun? Have you seen that? You feel cold, but you still get the sunburn, right? Or what will get the burns, because you will feel that heat. So if that any instrument in general, any instrument which can spread the light at different colors, now technically it will be different wavelength, unless that instrument is designed for that particular wavelength. Now I will come to a little bit more technical. It should have that refractive index for visible light. Now for infrared light also it should have that appropriate refractive index to spread that light. If you don't have that, we will not be able to see that light separated. And that's why for ultraviolet light, for example, if you take a little bit shorter wavelengths, that is also the case. And so only for visible lights. And that's why I give the example of glass. Although we are able to see through the glass, but not all radiation comes through the glass. Infrared will come. Some of the ultraviolet gets absorbed by glass. That's why going outside and sitting inside, but getting the sunlight will not give you vitamin D, for example. You have to really go in the sun to get vitamin D. If you sit inside where there is a glass, you might think that I get sunlight, but ultraviolet light, which is responsible for creating that vitamin D, will not get to the glass. That's why you don't sit in the AC car or AC chamber and you think that I will get vitamin D if I get the sunlight. Thank you.
Yeah, one more. Yeah. Yes.
So we can see some areas like there is no sunlight and sunlight. Okay, sir.
You go underground. You go underground. So there is some location on the earth. Okay. Yeah.
No light. How we can find this day is completed without light? How we can find? How we can find, sir?
How you can find what?
Yes,
Day, how it completes the day.
How when the day is complete?
How do we know? How do we know the day is completed?
So when first time when I went to United States, I went to a state called Michigan, and I went there in end of July, beginning of August. So then I was waiting outside to get it dark to have dinner. It was already 9:30 p.m., 10 o'clock. It was still daylight. Outside it is still daylight. Then they told me, you don't look outside and have dinner. You look at your watch. If it is 8 o'clock, you have dinner. So as you go towards north, that means now I am talking about latitude. As you go towards north, this thing will happen. Sun will be in the sky for entire day, nearly, especially if you go to poles. Now, Arctic poles, you will see the sun for entire day, nearly 24 hours. Now, if you go to Antarctica, that means the other pole in the south, it will not be there at all. So 6 months it is daytime, 6 months it is nighttime. So you don't define your day based on the sun. You define your daytime based on the clock. Fortunately, what has happened, and this is very interesting. Now, this question leads to very interesting thing. Then why India has an advantage, or India had an advantage developing astronomy? Because it is very close to the equator. So you can see now a lot of stars. You can see sun rising in the east and setting in the west. If you were at the poles, you could not do that. You understood? Why astronomy was developed mostly in India, in Greece, and that is the reason. So geographical location played a very important role in doing a lot of things, because they will not see sun for 6 months. So you lose that time and they will not see the planets going through this each constellation. And if you are given the responsibility to design the calendar, 1 month would be 6 months long. You understood, no? It's a very interesting question.
Yeah.
Okay. Sorry, you can
just say.
So thanks a lot for your exciting, thought-provoking, and full of mind-blowing questions. The entire lecture is filled with very interesting questions to probe ourselves in future answers. Thank you once again. Just now we were discussing about this. Chakrapani also agreed with me after seeing the questions from the audience. Now science department, science faculty has one more responsibility starting astronomy. So this match is there between the questions asked by the audience and also the situation here. So students have a lot of interest in the astronomy also. As Sir said, that our geographical location of our country also helps us a lot to develop so much of knowledge in the field of pathology, astronomy. So thank you very much, sir, for enlightening us for the new subjects. Definitely we take your help in future to start the astronomy course at the undergraduate level as one of these optional subjects to start with. So thank you once again. Before the formal vote of thanks, sir, we have a tradition of extending felicitations to our honorable guests. So, as a token of our respect, you kindly accept our felicitations. Now I request the who is conducting, Madam, please conduct this felicitations program. Sir.
That is the democracy of a visit to our university.
Now I request Koteshwarao to propose formal vote of thanks to this session.
Good afternoon, all. Respected dignitaries on the dais, distinguished guests of the dais, dear participants, and all our students. It is my privilege to propose vote of thanks now. On behalf of Faculty of Science, Dr. B.R. Ambedkar Open University, and my own behalf of, I would like to extend a heartfelt vote of thanks to each and every one of you for attending and making the Science Day celebrations a grand success. We are honored to have had the presence of our esteemed Vice Chancellor, Professor K. Sitaram Rao Garu, who graced the occasion as the president of the event. We'd like to express our sincere gratitude for his valuable time and insight that have inspired us all. Thank you, sir. You're always supporting and encouraging the faculty members to organize such kind of activities in the university. Our sincere appreciation and thanks to our chief guest, Professor Vital Tilvi, for not only accepting our invitation, but also spending immeasurable time and delivering wonderful talk on the topic exploration from deep ocean to deep space. Sir, we really enjoyed your lecture and inspired by your presentations. Your lecture is truly enlightening and insightful. Many thanks to you, sir. We thank the guest of honor, our academic director, Professor Ganta Chakrapani Garu, for sharing your views and expertise with us. We thank you for your constant guidance in all our academic activities. Our sincere thanks to our registrar, AVRN Reddy Garu, for his support and administrative sanctions for smooth functioning of such programs. We would also like to express our heartfelt gratitude to our beloved Dean Faculty of Science, Professor Pushpa Chakrapani Madam, for her constant and invaluable support for guidance throughout the event. And also, we thank Professor Saraswati Rao, former Faculty of Science member, and Professor Rajshekar Reddy Garu for attending this event. We thank Finance Officer and administrative staff for supporting finance sanction. We thank Computer Center, PRO branch, caretaker, and AVPRC for their tireless efforts in ensuring that the event went smoothly and efficiently. We thank the directors STD for his staff for cooperating in conducting the event and organizing the science exhibition inside the room of this hall. Finally, we thank all students, teaching staff, non-teaching staff, and service unions. Our special thanks to Charanya and non-teaching staff, our science faculty, for their cooperation and support for organizing this event. Thank you, everyone. Now, we invite you all to visit the science exhibition arranged in the beside room of this hall. Please attend that arrangements. Thank you, everyone.